This is problem 4 from the 2010 final. This problem asks, they did a survey, some teens in LA, and then based on the survey and the usual methods we learned, they said they're 95% confident that between 42 and 50% of all teens watch this show, Glee. I think that's the one about the singing, whatever. So they said, what is the fraction of students in the sample that watch Glee? Now you might say to me, oh, but Josh, we learned how to compute confidence intervals from the data. How do we go from the confidence interval back to what we saw in the data? Well, what's the rule? The 95% confidence interval, CI, is what? It's the sample mean, so in this case the sample proportion, plus or minus 2 times the SE of what? Times the proportion in this case. So we don't know any of these quantities. I don't know the sample proportion. I want to find it. I don't know the standard error. I don't know the standard error of the proportion. But what do I know? I know that my confidence interval looks like this. This is 42%. And this over here is 50%. But it's plus or minus 2 times the standard error with the proportion. So what does that mean? That the sample proportion is right in the middle of the endpoints. So what's in the middle of 42 and 50%? Well, it is 42 plus 4, so 46%. And that is the fraction of students in the sample that watch the show. Now we can go on and we can say, go to part 2, part B. They say approximate the number of students in the random sample. If this is not possible, explain why it is not possible. Well, exam taking tip, if they say something like this, that means it's possible. They're trying to get you. So how do we approximate the percentage of, the number of students who are in the sample? Well, what do we know? We know that the SE of the proportion is equal to the SD of the box divided by the square root of n, where n is the number of students who were in the sample. But what do we know about the SD of the box? We don't know it beforehand, but we know that the SD of the box was bootstrapped. Why do we know this? Because when we're doing a confidence interval for a proportion, we have to bootstrap the SD, because we just don't know what it is. We don't know. We have our box, we have our 0, we have our 1, but we don't know how many of each are in it. So what do we have to do? We have to bootstrap it. So we know that the proportion that were in the sample was 46. So we know that SD boot, which is SD box here, is the square root of 0.46 times 0 times 0.54. Right, this and 1 minus this. So we now have the SE of the proportion is this guy divided by square root of n, and we know that the width of our confidence interval, it goes from 46 to 50, 46 to 42. So the confidence interval looks like this. So we know that 4% equals 2 times SD box, which is the bootstrap, so I'm going to write boot from now on, divided by square root of n. And we'll do 4%. We'll change this to 0.04 because this is in units of proportion, not percent. So we have to change that. So what does this give us? If I divide by 2, I get 0.02 equals square root of 0.46 times 0.54, right? Remember, I got this because this is the bootstrapped SD, divided by square root of n. So now I can multiply both sides by n, by square root of n, and divide. So I can multiply by this, divide by this, so I can get square root of n equals square root of 0.46 times 0.54 divided by 0.02. And now that means I can square both sides. That's okay. Square. So then that means that n is equal to 0.46 times 0.54 divided by 0.02 squared. So we can just plug this into a calculator, and I'll just pull that up. And we get 0, so I'll just do that, 0.46 times 0.54 divided by 0.02 squared, and that gives us 621. 621. So, you know, there's some rounding in there. It's not exact, remember, because we bootstrapped the SD, but this is our best approximation. So now we knew how to go from a sample size and a standard error to a confidence interval. So now we've seen you can go backwards from your confidence interval to get your standard error and to get your sample size.